Good morning. This is Dan Lampe with Storm GPS. I'm reporting in on the Matlacha Bridge tornado that was generated from the outer bands of Hurricane Milton. If we look at the morning of the outbreak, October 9th, we had the location of Milton was out over the ocean producing 145 mile per hour winds. And at that point, it was still 120 miles off the coast of Florida. But the outer bands were already starting to reach Florida, and to look at the big picture, a massive outbreak was just starting to come on shore here. And as the day progressed, we had a historic outbreak really for the intensity of these tornadoes in these outer bands. Today we're going to focus on this first outer band, the Matlacha Bridge tornado, which Storm GPS, we provided an 18-minute advance warning into that area. So we're going to zoom into that particular storm track and show you how this transpired. So as this was coming on shore, the National Weather Service issued a tornado warning at 11:33 in the morning. And here's the Matlacha area up here that we're going to focus on. But Storm GPS, our algorithms draw a corridor out 60 miles for every warned tornado and thunderstorm in the United States. So as soon as the warning is issued, we draw the corridor. We provide ETAs every mile out the corridor. And as this day was progressing here, we'll look at the area of the damage up here in Matlacha and show you the actual tornado as it went over the bridge around a little bit after noontime. The pictures we got from the camera that's affixed on the bridge, you can see the tornado here in the upper left. It's approaching the bridge. Down here, it's actually going over the bridge, and it was producing about 125 mile per hour winds at that point in time. Storm GPS, from that initial warning, at 11:33 was that initial National Weather Service warning, and our ETAs out, we had it arriving here on 4th Lane and Cape Coral at 11:51. So that's an 18-minute advance warning that our software provided. So let's go back and just watch how this transpired. So we had the initial warning that was issued here by the National Weather Service at 11:33, and again we drew our corridor here. The next warning issued by the National Weather Service was at 11:47, and like I say, 14 minutes later. And what I want to point out here is our algorithm and our initial corridor that we drew. Look at how close the next National Weather Service warning, it was right on our Storm GPS corridor that we had generated prior. 11 minutes later, the National Weather Service issued another warning at 11:58, going again right into the area, right on our corridor. So, looking out here again, the big picture, we have three tornado warnings. We drew our corridors coming right in to this damage area. Again, we've got the picture that we showed. Here's the tornado approaching, here's the damage, here's where we had to end our ETA. So Storm GPS performed really well in this scenario. We've got many other examples that we're going to share with you on these outer band tornadoes, but it was a prolific outbreak, and this initially focused, like I say, on this first outer band that was, like I say, 120 miles. This is 120 miles off coast when this was being generated. So we wanted to go over and show you the accuracy of Storm GPS and what we do. This can help out your utilities if you're in the utility industry and looking at your infrastructure, 911 or emergency management, as well as any corporate safety where you really need to have the hyper-local focused ETAs that Storm GPS provides. Like I say, we do this on every warned tornado, thunderstorm, and marine warning in the United States. So this is a wrap for this Matlacha Bridge tornado, and we will be coming up with other warnings as they come up on this storm. If you'd like and subscribe, like I say, we will be sharing out the other videos from this situation. Thanks for watching.